I'm live, there's no way back. So used OBS keys. Why is there all on this side? So here we're doing type inference again. Should I say redoing it? And I'm not sure how to do it. I mean, there is this guy, Hindley Milner, which made a pretty good type system. And it's pretty simple, but implementing it, I have no idea how to do this. The problem is it is we if we just open this example, let's say we have a variables which we will have someday, one day maybe, to infer types on them, give a little bit more context. We will have generics as well, so actually imagine this example. We need to infer types of those variables. This is what we have, and I would like it to happen in one pass. The current system would require me to like go here. Okay, so this 0 is of type unknown because it's not specified, like I32 for example. Those variables then unknown as well, wildcards it's called. Next I have a clone, but since A is unknown and B is unknown, I can't really do anything here as well. Next we have F strict, which actually has a type which infers the type of this variable to be I128, and that's the first pass done. On the second pass we go here, see nothing changed here. Next we go here, we infer the type of this constant to be integer, 128 bits. Then on this line we infer the type of A, and then this line we already inferred. And the third pass we will say this is I128, and we finally done, and we actually have to do a fourth pass to ensure that we haven't missed anything, and we also have to somehow check if we could infer all types. So that was my idea, but I didn't like it. So this guy, Hindley Milner, not sure how to pronounce his name, uh, did a very simple solution. When we go, we infer types for this, which is t1, for example, and I'll actually say t1 is an integer. Then here we say t2. Hold on, then we infer types of a, which is t1 because it's the same of the same type as this. Next b, here we do t2, which is as well an integer. Then we infer types here. Next, fclone says that those are equal, and it works because we know that they are both integers. So we say that they are equal, and this is a tricky part where I have to replace all the types here by t1. And on the next line we see that t1 is actually an I128, which works with integer. And so we replace this by I128, and so we replace t1 by I128. And this is how this algorithm works. May also do something like this. Like here, when I have fclone, I may try to set this t2 to t1, for example, because they're fully compliant. But then some problems occur, and when I have strict b, how do I set both t2 and t1 to I128? I don't know. Maybe I should just say, like, if this is the same as t1, go into t1 and say that this is I128. But this is hard. This is just too hard. Oh, and after that, we will need to add an additional path that's gonna infer actually those t1 and t2. Replace aliases by actual types. And I don't know how to do this properly. It's like right now everything has a type, for example. I'll probably make this just a type, not a size. And where's types? Where are types? I may define something like this. So this type is the same as the other type, which is an async reference counted mutex, but this just doesn't work like that. Maybe, just maybe I should do something like a big map. Don't know, where I'll have AI. Stop it. Where I will have something like this. So like 0 is t1, and then I say an integer like this. Probably t1 will be an integer, then I say a is t1 as well. And then I go to b, here I say t2, let's say t2 is integer, Then here I say they are equal, so I move T2 to this list, because they now have the same type, and they strict will set this to I128. Maybe this is the way, but like having a table somewhere, I don't even have a place to store it properly. Implementation. Let's look at C++ variant. Oh, I don't even want to read this. It's too scary. Am I still alive? Just in case. Come on, Lord. Okay, guess let's look at the C++ variant. Looks pretty simple. Quite a lot of code. So using namespace, environment, type variable. So those three are variables, type variables. So they are probably using something I've described here, something like this. I don't know, maybe that's the way, but where do I store this table? Inside of a function, but then inner scopes. I don't know. Just don't know how am I gonna implement this. Okay, now I see what people mean by saying type inference is hard. I don't want to store this as a table. Actually, I have a struct called type inference info, which is per function. So I might store it here. And reporter is here, yeah. A ref cell to a mutable object. What was the problem of me making this mutable reference? Star. Was it passing it everywhere and then asking for a reporter? Okay, let's try and see. Because I don't remember why. I remember there was a problem of making this mutable reference. I don't remember what problem was it. I think it was like something was still borrowed. Yes, it's here. So yeah, I take a signature which borrows it immutably, and then I use it pass it mutably here. This is lifetime A, then have a lifetime B here. This is borrowed for B, and this is returned for A. Does this work? Maybe. Does this actually work? Obviously we have errors. Where? Oh, I mean, this makes sense. We have to make it mutable. And make it actually mutable. Oh wow, was it that simple? Like really? Okay, so this is a function which I'm gonna go back to soon. Now I can get rid of this ref cell. Just leave it as a mutable reference. And also I need to add a table. Public. What's this? Type table. But how do I make this table? Like I'll have a vector of tuples of vector send types. Vector. Let's say string for now. And the type. But how am I gonna store types? I have no idea. Like literally. After type inference, I need this type table to be done. Let's look at an expression. Where is an expression? This I think. No, it's types this. Yeah, this one is an expression. So none of them really hold types here. Except as a constant and the function call actually have some type impact. Function call just pulls types from other places, and inferring types in function signatures is I don't wanna do this. I don't want to even think about it. So right now I only have a constant as something that I can infer, which will have a type instead of size, which may be specified or not specified. And if it is specified, I can just say it's Okay, so wildcards should contain type references to a type table. I mean, this is still a pain. Instead of a size, I'm gonna have a type, which is a type or type of this literal, and same thing here. Um, um, if the type is baked in somewhere, I still may have if here say if type type r hash type, which I should put here, is not wildcard. I'll just write this type. R hash type. Imagine having a pointer literal. This is kinda useful, but at the same time, like why? It will be so rare that there's no point of making this a language feature, but I can do it so easily. Type. Oh, and I need to use this as well. So then, if you don't care about missing field, you can explicitly ignore it. No, I do care about types here and here as well. Or hash type. And I mean, I'll rewrite this all anyway. Still have some errors in this file. Why is it saying? Oh, yes, size and type. I need value and type. What can I do to make it work? Like I can make wildcards point into a table. But now, like wildcards will have to have an identifier. Where is the type module? Here it is. So here I have all the basic types, and pointer should be here, here. Then the unit type is temporary, and actually custom type will go here. Probably leave it like that. Then I'll have wildcard and errors, and error type, and also I'll have a type inferring. Inferring, and this will have some kind of ID. Or should I just point to a cell in the table or something like that? So, like all those IDs will be pretty much, all of them will be unique. So why would I do this? Like if I have, wow, I have so many things open. I need to close some of them. No, I need to fix this. This is a reporter. And the type table is a new vector. And vector is not the best idea for this. Maybe there is another implementation I can take a look at. YouTube Alive. Hindley Mailer type system. A Haskell library. I don't know how to read Haskell code. Don't write it, I don't read it. Reconstructing TypeScript. I need to see an implementation of this. But like this C++ implementation references this Python code, which doesn't load for me for some reason. JSON queries mode page load may be impacted. I mean, it doesn't have anything. GitHub contact and okay, let's just look it up. And Milner type inference. How to implement it in Python. Oh wow. Actually, there's a lot. This was the referenced one. This doesn't work for some reason. Okay, so one thing. This code is taken from a blog post, but this blog post doesn't work for some reason. Actually, I may try just enabling VPN. Maybe it's not my fault. So I guess we'll just have to try to read through this code and understand it. It's quite a big chunk of code. And I don't understand languages like Haskell. Without them, I can't really read this. Read the docs. husk. No, don't wanna look at it. Okay, let's look at this Python. Environment type variable. What's a type variable? So standing for an arbitrary type. All type variables have a unique ID, but names are only assigned lazily when required. Next variable name, stir, name ID. So yeah, this is basically just an ID, and I guess they have a table into which they index with this ID. I mean, not really index, but whatever. Type operator, asterisk. It's a type operator. An array type constructor which builds a new type from old. Name types, I guess. Okay, so try exp. Evaluate a type here. Analyze. Environment. If it's an identifier, get type. If it's an instance, and analyze. Unify. Oh wow. An apply function. Analyze. Lambda. A let statement. Let rec. New environment. Node v. Add type. V, I mean equals type. Guess let's just do the same. That means it's still a pain. Where is the type module? This one, inferring. Inferring will hold a U64 ID. Okay, so this is a type of variable that is held in type table. Type can be moved in the type table. I mean, having so much different types make me sick already. I don't know. I just don't know. Right now the only thing that holds the type is a constant. Here it is. Maybe make it again. Maybe I make it an ARC of a type. An ARC of a mutex of a type. I mean, I can't just use type in indices, because type table is actually not stored anywhere. Or I might store it in a function, but since it's hard. But then I probably get generics for free. Where's the function? Where can I find the function? So lost. See, this function is it has a body and a type table. Maybe make this a tuple or something like that. Because I need to ref cell. I don't want to have two ref cells, I want to have one ref cell per two fields. This is so annoying. Okay, let's have two ref cells. Type table. How do they store a type table? They have a node.v. I don't know. I have no idea what this node.v is. I have no idea. Maybe look up at C++ implementation. I mean, look it up. Operator. The type table. This type. Okay, this doesn't matter. Static const int. Okay, those are types. Make a function that takes only one argument, but I mean, sure. What is this? Definitive. Oh, it's oh yeah. I'll need to do this, unfortunately. So title ready. He can't read it. Just say it's a mapping from whatever. I need to somehow generate this AR. I need to keep it in mind, because just making it the lowest level AR, which is easy to work with, won't work, because I need to top level languages to generate this. They don't know how. Like if we go into parser, this says safe land, which probably has some errors here. Like for example, into a function, the function takes, like, parses a signature, creates a function, and then as a block I'll probably need to get this into a separate variable and use it and then set it. And here's an expression. So let's go into an arbitrary expression. So like I'll have like a type in for type table here, or a function basically, and I'm gonna need to put some stuff into it. Like constant. I can't just return a constant. I'll need to register it. That's why making an AR is a pain. Might need to redo the whole thing. 42 minutes, I haven't done anything. And I'm so tired already of this. Maybe I need to go outside on a bike ride. But yeah, I'm thinking of making the IR like more low level, but providing a functionality like CraneLift does. Well, CraneLift provides two low level functionality, but it has some. I heard that it's nice variable interface. It's like as they can do in a parser. For example, here instead of just returning a constant, I'm gonna do like a function which I'm gonna pass into a constant, and this will return an expression by itself. Yeah, a short stream. Maybe I'll come back later today when I clean up a place for me to stream easier. I wish someone of them were live. Like, where did Madhouse Steve haven't streamed in 7 months? John Kiro haven't streamed in 2 months. I wish they came back. Yeah, they have to discover someone else. Language, English, viewers low to high, beginners, Rust, no, other language. Anyone doing compiler development? No. Like literally no one is doing Rust even. Who am I supposed to raid? Building a blog. There's so many game devs. Why not to move it into a separate category? Well, I mean, yeah, kinda. Oh, there's not a lot of channels here streaming in English. I could raid them, but 44 viewers, too much. Why am I deciding who to raid if I don't even have viewers? CCG. I mean, I need to make friends somehow. Okay, let's get rid of language. Any language will do. I mean, any. Rust. Rust Tokyo. No English. No specification of a language. Rust lang. Rust lang. Compiler.
muito grande é muito arriscado. Pra ser honesto, assim, ó.
It's not English. Yeah, maybe.
Trying to think. I guess like here we could wrap it in another function. So what this will really do is just call change health